Chapter 3, Section 2, Types of Data in Machine Learning. In this section, you will learn three types of data: structured, unstructured, and semi-structured. First, I will explain what they are and their concrete examples. Second, I will explain what are advantages and challenges of using each type of data. In analytics using machine learning, we can use various types of data to build models that can make accurate predictions and decisions. Three main types of data are used in machine learning: structured, unstructured, and semi-structured. In the following, let's look at the characteristics of each type. Structured data is data that is organized in a predefined format or structure. This data type is usually stored in a tabular format, such as a spreadsheet or a relational database, and consists of rows and columns. Each row represents an individual record, and each column represents a feature of the data. The individual record represented by each row is also called an observation, case, or data point. Sometimes they are simply referred to as data. A feature represented by each column is also called an attribute or variable. In structured data, each attribute is stored and processed following a set of rules. The structured format allows for efficient analytics. Structured data is used in many real-world situations, including business, healthcare, and scientific research. For example, customer data, including customer records such as name, address, phone number, and purchase history, is often stored as structured data. This type of data is often used in machine learning models for customer segmentation, churn prediction, etc. Financial transaction data, including records of sales, expenses, profits, and losses, is often stored as structured data. This type of data is often used for credit scoring, stock price forecasting, etc. Structured data has several advantages in the use of machine learning. The first is ease of use. Because structured data is organized in a consistent format, it is easier to understand and less prone to errors, missing values, and other problems at the data preparation stage. Thus, we do not need to do much preprocessing. The second is compatibility with machine learning algorithms. Many machine learning algorithms, such as linear regression, decision trees, and support vector machines, are designed with the assumption that the input is structured data. The third is efficient storage and retrieval. We can efficiently store structured data in relational databases. Thus, we can easily retrieve and manipulate large datasets to train machine learning models. While structured data has many advantages, its use in machine learning presents some challenges. The first is limited flexibility. Structured data follows a rigid format, which can be a limitation when dealing with complex or new types of datasets. Second is the loss of context. Because structured data is stored in tabular form, contextual information can be lost. For example, text-based reviews stored as structured data may not capture the emotions and nuances expressed in the review. Third is data sparsity. Structured data can be a dataset that contains many missing values or cells with zero values. machine learning models often have difficulty learning patterns from such sparse data. Unstructured data is a dataset that has no predefined data model or structure. Since no consistent format exists, unstructured data can be with various data types. For example, unstructured data includes text data, such as documents and emails, and multimedia-based data, such as images, audio files, and video. This diversity allows unstructured data to contain rich information, but its complexity makes data preprocessing and analysis complex. With the proliferation of digital content and social media, the collection of unstructured data has become easier, and its use has increased rapidly. Common examples of unstructured data include text, image, audio, and video data. Text data includes documents, emails, blog posts, social media comments, and product reviews. Image data includes photographs, scanned documents, medical images obtained from X-rays and MRIs, satellite images, etc. Audio data includes phone conversations, podcasts, music files, and speech recordings. Video data includes videos obtained from security cameras, video streaming platforms, and social media. In analytics using machine learning, unstructured data has the following advantages. The first is the richness of information. Unstructured data often contains more subtle and detailed information than structured data. For example, a customer's product review contains not only a rating score, but also text detailing the customer's feelings, opinions, and experiences. Second, unstructured data excels in real-world representation. Unstructured data captures the complexity associated with human language, behavior, and vision. Thus, we can train machine learning models from diverse and realistic data sources. The third is broad applicability. Many of the advanced machine learning applications widely used today have been trained on unstructured data, such as language, images, and audio. The advancement of deep learning techniques enables us to develop various AI products using unstructured data. While unstructured data has advantages, it also has challenges. The first is complexity in processing. Since there is no predefined format, unstructured data needs complex processing to be ready for analytics. Second is the difficulty in storage and management. Unstructured data may require specialized storage and management because of the variety of formats. In addition, the data size is often enormous, so large storage capacity may be required. Third is quality and noise. Unstructured data is noisy and inconsistent, making it difficult to ensure data quality. For example, text data may contain misspellings, slang, and unnecessary words. Also, image data may have inconsistent resolution or be affected by lighting conditions. Fourth is computational resources. Analyzing unstructured data often requires significant computational resources, especially when we use large datasets and complex models such as deep neural networks. Semi-structured data refers to data that does not follow the strict structure, but it has characteristics that make it easier to analyze than unstructured data. Unlike structured data, which consists of rows and columns, semi-structured data contains tags, markers, key-value pairs, etc., and there is some structure and hierarchy within the data. The main characteristic of semi-structured data is that it has both flexibility and a certain level of structure. That is, semi-structured data can represent complex and diverse data formats, and also retain characteristics that facilitate data processing and analysis. Semi-structured data is used for various applications, including web development, document management, and data integration. Examples of semi-structured data include JSON, XML, HTML, email, and log files. JSON is a lightweight data interchange format that uses human-readable text to transmit data objects consisting of attribute value pairs. Because of its simplicity and flexibility, JSON is widely used for data exchange in web applications and APIs. XML is a type of markup language used to describe the appearance and structure of text and is mainly used to simplify data interchange and management. It is commonly used for data interchange between systems, such as web services and configuration files. HTML is another type of markup language. When creating a website, it provides configuration instructions to the computer and forms information such as text and pictures to be displayed. It contains tags and attributes that provide a structure for displaying content on the web, but is not organized in a strictly tabular format. Emails often contain structured metadata such as sender, recipient, and timestamp, etc., and unstructured text in the message body. Log files, which are records of emails sent and received, have a consistent format for recording events and errors, but often contain diverse and unstructured messages. In data analytics, semi-structured data has the following advantages. The first is flexibility and adaptability. Semi-structured data allows for a flexible representation applicable to various data types and formats. This flexibility facilitates integration with diverse data sources. Second is the ease of data exchange. Semi-structured data is well suited for applications that require interoperability, such as web services, APIs, and cloud-based solutions. Third, it is highly capable of handling complex data. Semi-structured data is well suited for representing complex structures that do not fit tabular formats well. Thus, it can capture intricate and hierarchical relationships of complex objects, such as customer profiles and product catalogs. While semi-structured data has advantages, it also has challenges. The first is time and effort required for data preprocessing. Converting semi-structured data to be usable in machine learning analytics requires complex preprocessing, which takes time and expertise. Besides, semi-structured data often lacks the consistency and regularity of structured data, compromising data quality and integrity. Moreover, semi-structured data often contains problems such as variations in data format, missing tags, and inconsistent attribute names, which makes data processing and analysis difficult. The second is the difficulty of storage and retrieval. Storage and retrieval of semi-structured data can be more complex than for structured data, especially when dealing with large amounts of data or complex data structures. Databases such as NoSQL are designed to handle semi-structured data, but require more sophisticated indexing and query techniques to access the data efficiently. Let's summarize the key points of this section. Structured data is organized in a predefined format. Structured data is widely used because of its usability, algorithm compatibility, and efficient storage capabilities. However, there are also challenges such as limited flexibility and possible loss of context. Unstructured data provides rich information to develop models that can perform complex tasks. Despite its challenges in processing, storing, and managing, unstructured data has potential for innovative AI solutions. Semi-structured data provides a balance between rigorous structure and flexibility. Despite some challenges in processing and consistency, it has strength in representing complex data structures and facilitating data exchange. Thank you for watching. Please thumbs up and subscribe to my channel.